In the previous video, Max talked about atoms. Atoms are the basic unit of matter. And he also talked about compounds. And remember that compounds are when atoms come together. So when they come together, this process is called bonding, which I'm going to be expanding on in this video. So there's two types of bonding. There's covalent bonds and there's ionic bonds. Let's first talk about what a covalent bond is. Now, when we're talking about bonding, we focus on the valence electrons within an atom. The valence electrons are the electrons which are in the outer shell of an atom. Okay, so in the case of fluorine, fluorine has 7 valence electrons. Atoms typically want to have 8 valence electrons within their outer shell. So what they're going to do is that they're going to share these electrons, and both fluorine atoms in this case can have 8 valence electrons. So they're going to form a bond. This is called a single bond because each fluorine atom is donating 1 valence electron. Okay, so this fluorine atom is going to end up having 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine atom is also going to end up having 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this sharing of electrons is called a covalent bond. In the case of oxygen, oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. So what it's going to do is that it's going to bond, and it's going to create a double bond, because each oxygen atom is going to give 2 valence electrons within the sharing, and they're going to form 2 bonds. And then that way, each oxygen can have 8 valence electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7, 8. For this oxygen atom, 1, 2, 3, 4, 5, 6, 7, 8. For this oxygen atom right here. Now, we have covalent bonds, but covalent bonds themselves can vary. There's 2 types of covalent bonds. There is a polar covalent bond and a non-polar covalent bond. In a polar covalent bond, the one atom is going to have a greater pull on the electrons than the other atom. So there's going to be an unequal sharing of the electrons. So in the case of water here, the oxygen atom is going to pull on the electrons within the covalent bond here more than the hydrogen atom. This property of oxygen is called electronegativity. So oxygen basically has a greater electronegativity than hydrogen. It has a greater pull than hydrogen. And that unequal sharing of electrons within these bonds over here is going to create a polar covalent bond. Now, in the case with fluorine and oxygen, a fluorine molecule, F2 and O2, the 2 atoms pull on the electrons equally. They both have the same electronegativity. Because they have a equal pull, you can kind of think of a tug of war. This oxygen atom is pulling this way, this oxygen atom is pulling the electrons that way, but since they have an equal pull on each other, the pulls kind of like cancel out. And because they cancel out, the electrons within these covalent bonds over here are being shared equally. So that's a non-polar bond, covalent bond. So basically what you have to remember, just to recap, a polar covalent bond is where the electrons are being shared unequally, and a non-polar covalent bond is where the electrons are being shared equally. If you want to learn more about this and get more details about electronegativity and all these cool things, go check out Simple Chemistry. Okay, now, so back to water, we have a polar covalent bond here and here. Now that's going to do interesting things to the molecule itself. Since the oxygen is pulling on the electrons here, all the electrons are going to get pulled to this side, the top side of the molecule. Since there's more electrons on the top side of the molecule, this side of the molecule here at the top is going to have a negative charge, a partial small negative charge. Okay, because all the electrons are coming up here, electrons have a negative charge, so if all the electrons move to one location, that place is going to be negative. So they move, all of them move to the top, and this side of the molecule has a negative charge. And since all of them are being pulled by the oxygen to the top here, these hydrogen atoms here, their nuclei have a partial positive charge, because remember, atoms are made of protons, neutrons, and electrons. If the electrons are being pulled away, all that's going to be left is the protons. So this side is going to have a partial positive charge. Okay, now just because a molecule has polar bonds doesn't mean the molecule itself is polar. Okay, polar bonds is talking about the sharing of electrons. A polar molecule is talking about whether an atom has a partial positive and negative charge. So in the case of carbon tetrafluoride, even though the bonds are polar, the unique shape of the molecule makes the molecule as a self not polar, non-polar. If you want to learn about more how you can see that, again, go check out Simple Chemistry. So this is a polar molecule, this is a non-polar molecule, although both of them have polar bonds. Okay, so that's what covalent bonding is. Ionic bonding is a little more simple. In ionic bonding here, the electrons are actually going to be nabbed away by one of the atoms within the ionic bond. So sodium has 1 valence electron, chlorine has 7. Instead of creating these nice little bonds like we see here, what chlorine is going to do is it's going to be like, hey, I'm just going to take sodium's valence electron, so it can have 8. What that does is that since now that chlorine has taken sodium's valence electron, it has more electrons itself than protons, so it's going to have a slightly negative charge. So the chlorine is going to have a -1 charge, and the sodium is going to have a +1 charge, because now that it's lost its electron, it has more protons than electrons. Okay, so since the sodium has a positive charge now, and the chlorine has a negative charge, these charges, these opposite charges are going to attract, and when they attract, that attraction is the ionic bond. So bonding, covalent bonds, ionic bonds. Again, if you want a deeper explanation to this and you don't really understand my brief explanation, go watch my whole unit on bonding in Simple Chemistry.